Welcome to the Explainer. Today, we are diving into a machine that is so fundamental, so absolutely essential, that it's often called the mother of all tools. We are, of course, talking about the lathe.
I mean, that's a pretty bold claim, right? Calling it the mother/father of the entire tool family. But you know what? It's really not an exaggeration. Just think about it for a second. How do you make all the precise screws and the gears and the shafts that you need to build other machines? Well, a lot of the time you start right here.
So, what is it that makes this one machine so incredibly important? To figure that out, we're going to have to trace its journey through history, get a handle on its surprisingly simple core idea, and then we're going to explore the anatomy that makes it all tick. So let's start at the beginning.
Okay, Section 1, the mother of all tools. To really appreciate what the lathe is today, you have to understand just how far back its story really goes. You see, the lathe's history is really a story of evolution. I mean, it starts with these early wood lathes way back in 16th century France. But the real game changer, that was the Industrial Revolution. The moment machinists in England figured out how to adapt it to cut metal, they basically unlocked the ability to create precise interchangeable parts for everything. Steam engines, factories, you name it. And that's exactly why it earned the nickname engine lathe, because it was the machine that built the very engines of progress.
All right, Section 2, how a lathe works. Now, for all its history and its industrial might, the secret to the lathe's power is, well, it's almost poetic in its simplicity. That is the entire principle right there, in one sentence. A rotating workpiece meets a stationary cutting tool. That's the magic. The machine spins the material, and a sharp, fixed tool is carefully moved in to peel away layers, carving out a brand new, perfectly symmetrical shape. It's this simple, elegant dance that lets you create almost any round part you can possibly imagine. So, on to Section 3, anatomy of the machine. How does the machine actually pull off this simple principle with so much power and so much precision? Well, to understand that, let's break down the key parts that make it all happen.
We're going to use this diagram as our map for this little tour. I want you to think of the lathe as this compact, powerful factory where every single component has an absolutely critical job to do. And just like any good structure, it all starts with the foundation.
Everything, and I mean everything, rests on the bed. This is the machine's backbone. It has to be incredibly heavy and super rigid because any flex or vibration here would completely ruin the accuracy of your cut. And let's get a little closer at the materials here. The bed isn't just any old chunk of metal. It's typically a really heavy, seasoned cast iron that's alloyed with nickel and chromium. Now, that specific recipe gives it incredible strength and wear resistance. But here's the most important part. It is brilliant at damping vibrations. That stability is the whole secret to a smooth, precise cut. And running right along the top are the ways. These are perfectly flat, machined tracks that guide all the other moving parts.
Now, bolted firmly to the left end of that super rigid bed is the powerhouse of the entire machine.
This is the powerhouse of the lathe. The headstock is bolted permanently to the bed, and it really has two main jobs. It houses the motor and all the gearing to spin the workpiece at all kinds of different speeds, and it holds the workpiece itself, usually with a part called a chuck. Right at the heart of the headstock is the spindle, this strong, hollow shaft made of high-grade carbon or nickel-chrome steel. It has to be incredibly tough to handle the immense forces of cutting and high-speed rotation, all while making sure that workpiece spins with absolutely zero wobble. So if the headstock is the fixed powerhouse over on the left, what's going on at the other end of the machine? Over on the opposite end, we've got the tailstock. Now, unlike the headstock, which is fixed in place, the tailstock is designed to slide freely along the bed's ways. And this mobility is key because it lets it perform two very different but equally crucial functions. First, it acts as a critical support. It holds up the far end of a really long workpiece to keep it from flexing or vibrating while you're cutting. Second, it can actually hold tools. This lets you do operations right on the central axis of the workpiece, like drilling a perfectly centered hole, or reaming it to make that hole incredibly precise, or even tapping to cut internal threads.
All right, so we've got the parts that hold and spin the work, but what about the cutting tool itself? What's its chariot that carries it along the bed?
That would be the carriage. This entire assembly is basically the operator's control center. It rides along the bed's ways, and it holds the cutting tool. Its different hand wheels and levers let the operator move that tool with incredible precision, either manually, by hand, or automatically.
And that automatic movement, well, that's the key to one of the lathe's most incredible abilities, cutting perfect, uniform threads for a screw.
So here's how this ingenious system works. The carriage has a mechanism called a half nut, and it can clamp down onto a long, threaded rod called the lead screw. Now here's the really clever part. The machine perfectly synchronizes the rotation of that lead screw with the rotation of the workpiece. So when the carriage is locked on, it gets pulled along at a perfectly consistent rate, which lets the tool cut a flawless spiral thread. It's just brilliant. Okay, on to our last section, shaping the modern world. So now that we've broken down the anatomy of the machine, let's kind of step back and think about its larger impact and the responsibility that comes with using all this power. I mean, it should go without saying, but any machine this powerful demands respect. A high-speed spinning workpiece and a sharp cutting tool, that is an unforgiving combination. That's why proper personal protective equipment, or PPE, especially eye protection, it isn't just a good idea. It is absolutely non-negotiable. So if there's one thing to take away from all this, it's that elegant core principle we started with. A spinning workpiece meets a stationary tool. Every single part of this machine that we've looked at, the heavy bed, the powerful headstock, the precise carriage, it's all designed to serve that one simple, powerful idea. So just take a moment and look around you. How many objects in your world right now, from the little screws holding your furniture together to the intricate parts inside your car's engine, how many of them began their life as a spinning piece of metal on a lathe? It's a truly foundational technology, quietly and precisely shaping the entire modern world.
Please like, share, and subscribe for more learning and appreciation. I am Batman.